Welcome back. In this video, we're taking the next step in our dungeon generation journey by creating the logic to render the walls around the floors. This is an essential part of bringing your dungeon to life visually, and it ensures that the environment feels structured and immersive. The goal here is to automatically determine where walls should be placed based on the layout of the floor. To do this, we'll be using a powerful tool called bitmasking. Bitmasking allows us to calculate wall placement by analyzing the floor tiles surrounding each wall tile. Let's look at a smaller section of this dungeon layout here so we can walk through the process and get a feel for how this will work. First, we will loop through every tile in our tile position hash set. Let's do that by hand for a few tiles and highlight which positions will be wall tiles. Let's start at the top left corner of this room. First, we'll need to check all 8 of the tile's neighbors. These 8 directions are top, top right, right, bottom, bottom left, left, and top left. We will check our neighbors starting with the top and continuing in a clockwise direction. Let's check the top neighbor. We can see that this neighbor is not a floor tile, so it will be a wall position. Next, we'll check the top right neighbor. We can also see that this will be a wall position. We can continue in this fashion until all neighbors have been checked. After checking every neighbor, we'll see that we have 4 wall positions as neighbors to this tile. And after we process every floor position, you can see where the wall tiles will go. Every position outlined in orange needs a wall tile to be rendered on the tile map. Using this information, we'll construct an 8-bit binary string where each bit represents a specific neighbor, whether it's a floor or not. A 1 means that it's a floor, and a 0 means that it's a wall or an empty space. Let's go through a couple of wall positions so we can get a better understanding of how we'll create this bit mask. Let's start at the top left corner of the room. For this wall position, we're going to check our top neighbor first. And we can see that this is not a floor tile, so this neighbor will get a value of 0 in our bit mask. Then we'll check our top right neighbor position, and we can see that this is also not a floor tile, so this one will also receive a 0. Next, we'll check our right position, and this position does not contain a floor, so this one will also be a 0. Then for our bottom right, this is a floor, so this one will be a 1. Our bottom is not a floor, so it's a 0. Our bottom left is not a floor, so it's a 0. Our left is not a floor, so it will be a 0. And finally, our top left is not a floor, so it will be a 0. So with this, let's go ahead and construct our bit mask. So starting at the top and working in clockwise fashion, we will see that our first position will be a 0. Then we'll move over to our top right. This will also be a 0. Then we have our right, that'll give us the next 0. Our bottom right will give us a 1. Our bottom will give us a 0. Our bottom left will give us a 0. Our left will give us a 0. And lastly, our top left will also give us a 0. And so here you can see what the whole bit mask will be. It will be 0, 0, 0, 1, 0, 0, 0, 0. And this will tell our code that we need to put in a top left wall corner into this space. So let's do another one for practice. You can pause the video here and try it out on your own. What is the bit mask value for this wall position? To find the bit mask value for this wall, we will follow the same steps as we did before. We're going to look at each neighbor around the wall position, starting at the topmost neighbor and continuing in a clockwise direction. Each neighbor that contains a floor tile will get a value of 1, and each one that contains another wall position or an empty space will get a value of 0. You can see the values here. So let's go ahead and create our final bit mask value from this tile's neighbors. So first we'll start at our top again. This will be a 1. Then we'll move over to our top right, also be a 1. The next value will be 0, 0, 0, 1, 1, 1. So our total bit mask value will be 1, 1, 0, 0, 0, 1, 1, 1. Make sure that you have a strong grasp on this part because it's the most confusing part of the section, and it's also a central concept to rendering the tiles on the tile map. So go back and rewatch anything you might need to. Okay, so now that we understand what we're going to be doing, let's go ahead and start implementing our code. So first we're going to go ahead and create a new C# script. And I'm actually going to go down to the scripting and I'm going to just say empty C# script. And this is going to make sure that it's not a mono behavior, it's just a regular class with the name that we're going to be using, which is wall generator. Okay, so once the wall generator script is finished building, we'll go ahead and open this and you'll see that we end up with an empty class. All right, so for our wall generator script, we're going to first create our entry point into the script. So this will be a public void generate walls function. All right, so in order to generate our walls, we're actually going to need a little bit more information. We're going to need our floor tile positions, and we're going to need a reference to our dungeon visualizer, so that way we can draw it on the tile map. So let's add those as parameters. So our floor positions are hash set, so we'll say hash set of vector to int. And then we'll just call this floor positions. And then we'll also need our dungeon visualizer, which I'm just going to say dungeon visualizer. Okay, so now that we have those, we can go ahead and start adding our logic. So first we're going to need to create a new hash set inside here of vector to int, and this is going to contain all of our wall positions. So I'm just going to call it wall positions. And instead of setting this equal to a new empty hash set, I'm actually going to use a helper function to help us find all of our wall positions. So let's give that a call. So we'll just call this find wall positions. And this is going to need our floor positions in order to find our wall positions. All right, let's go ahead and generate this. And we'll go ahead and get rid of that exception. And we'll move down to our find wall positions function and start filling it out. So again, we're going to need to create a hash set of vector to ints, and this is going to be our wall positions. And this one is actually going to be the one we're returning to our caller. So this one we're going to set to a new hash set. And then just beneath that, we're going to loop through all of our floor positions. So we'll say var position in floor positions. Okay, and then so for each floor position, we need to check each neighbor. So to do that, we're going to need to know which directions to check. So let's go ahead and create a private list that's going to give us these so we can easily loop through them. So we'll say private list, getting ahead of myself there, the list of vector to int, and I'm going to call this directions. And this is going to be a new list of vector to int. But instead of closing it off like how we normally would, we're actually going to use curly braces instead. And this is actually going to allow us to define our list manually. So let's go ahead and save. And then inside of this list, we'll add a new vector to int. And I'm going to copy and paste this a few times just to make it easier. So you have our top right, right, bottom, bottom left, and top left. So I'm actually going to just label those all real quick. So we'll say top right, right, bottom right, bottom left, and top left. Okay, so that's all of the directions. So now we just need to fill in their values. So our top is going to be 0 on the x and 1 up on the y. Our top right will be 1 on our x and 1 up on our y. We'll say 1 on our x and 0 on our y. Our bottom right is going to be 1 on our x but a negative 1 on our y. Our bottom will be 0 on the x and negative 1 on the y. Bottom left is going to be -1, -1. Oops, I put that in the wrong order. Our left is going to be -1, 0. And finally, our top left is going to be -1 and 1. All right, so now that we have our directions list, we can go ahead and loop through them in our find wall positions. So we will say for each var direction in directions. And we can use our direction and our current position to calculate our neighbor. So let's go ahead and do that. So we'll say var neighbor equals our position plus the direction. Okay, and then we're going to go ahead and check to see if our floor positions does not contain our neighbor position. So we'll say if not floor positions dot contains neighbor. So if our floor positions does not contain our neighbor, we'll go ahead and add this neighbor to our wall positions. Okay, and once we've processed every position in our floor, we're going to go ahead and return all of our wall positions. Wall positions. Oh, it's completing it for me. Okay, so there we go. That is our find wall positions function. Next, we're going to create a new function to help create our walls for us. So let's go ahead into our generate walls function, and we're going to call the create walls function, and this is going to need our visualizer. So this is our dungeon visualizer. It's going to need our wall positions, and it's also going to need our floor positions. So let's go ahead and generate this method. And we'll get rid of this exception, and now we're ready to start the logic in here. So the first thing we're going to do is just get our walls to show up. We're not going to worry about saying which wall we should use quite yet. So let's go ahead and loop through each of our positions in our wall positions list. So var position in wall positions. And then we're going to create a function to paint our wall positions onto our tile map. So we will say dungeon visualizer dot paint wall tile, and we're going to pass in our position, and we're going to pass in a wall tile that we want to use. So for me, I'm going to want to use a default wall tile just for this step. So let's go ahead and head up to the top of our class, and then I'm going to create a header just to help keep things organized. We'll say default tiles. And we'll say public tile base, and then I'll just call this default wall tile. Okay, and then we'll scroll back down and we'll just pass that default wall tile into this function. And we'll add our semicolon, and that is it for that. So next we need to go ahead and generate this function. So we'll use our command period command, and then I'm going to hold down command and just click on this, and it will take me right to that definition inside our dungeon visualizer script. And then we need to make some adjustments to our function signature. So instead of an internal void, I'm going to go ahead and make this public. And then instead of default wall tile for our tile base, I'm just going to call this wall tile. Great, we'll get rid of our exception, and then we can start filling this one out. So this one's going to work really similarly to our paint floor tiles. So instead of looping through them, we're only be given one wall tile position at a time. So we can just go ahead and straight up call paint tile. So let's do that. And paint tile takes in a couple of parameters. So our first parameter is our position. So we'll pass the position in that we gave the function. And then it needs to know which tile map we're going to use. And our dungeon visualizer already has the tile map, so it's called wall tile map. So we'll use that. And then we're going to use the wall tile that we passed into the function. And this will paint all of our wall tiles onto our tile map. All right, so if we head back to our wall generator, we can see that that is complete. We'll just need to go ahead and add a keyword to the top of our class here called serializable. And what this is going to do is it's going to allow us to see all of our fields in this script in our inspector once we reference the script through our dungeon visualizer, which is what we're going to do right now. So heading back to our dungeon visualizer, we'll scroll up to the top, and just under our floor tiles section, we'll create a new header. And I'm going to call this wall generator. And I'm going to create a public wall generator, and then I'm going to just call it wall generator. Okay, and now that we have that reference, we need to call the generate tiles through it. So we're actually going to do this in our paint floor tiles function because At this point, we're starting to add our floors. So we'll just say, hey, do you also want to add your walls? And if that is a yes, then we'll go ahead and add the walls. So to do that, we're going to add an optional parameter to our parameters list. So we'll say comma, bool, generate walls, and we're going to set that equal to true. Okay, so for those of you who don't know, an optional parameter is just a parameter that we give a default value to. So and it kind of just means like what it sounds like it means. It means that you don't have to pass in a value for this if you don't want to. So let's go ahead and take a look at our paint floor tiles call in our dungeon generator. You can see that we actually don't have any errors because that's an optional parameter. If it wasn't an optional parameter, this would be like, hey, you don't have enough things going into this function. But because it's optional, it's going to default to true if we don't pass anything into it. If we decide that we didn't want to generate our walls, we could pass in false, and that will make sure that we don't generate our walls. Or if you wanted to be like super clear, you can just also pass in true, so that way you'll have the same number of parameters that the function takes in. But it isn't necessary, it's optional. So we can save this as how we had it before, which is what I'm going to do. I'm going to leave it like this. All right, so let's go back to our dungeon visualizer and finish up our logic in our paint floor tiles. Now that we have that optional parameter, we're going to check if our generate walls parameter is true. And if it is, then we're going to go ahead and call the generate walls function on our wall generator. Okay, so this is going to need two parameters. It's going to need our floor positions. And it also needs a reference to the dungeon visualizer, which is what this script is. So we'll just use the keyword this to pass in the reference of the dungeon visualizer. Okay, so that is that. We'll go ahead and save, make sure everything is saved, and then we'll head back to Unity. And we're going to need to set up a couple of references here before we can test it out. Let's click on our dungeon generator, and you can see that we have a default wall tile here. So let's go ahead and give it a wall tile to use. So I've actually already set up my wall tiles. So if you haven't done this, go ahead and import your sprites and make sure you set up your wall tiles using the same method that we used for our ground tiles. And then once you're ready to do this next step, just come back and follow along at this point. But if you've already got these set up, then we can go ahead to our generator. Select the wall tile that we want to use. I'm actually going to use this dark brown one because that makes it super easy for me to see that there's actually no wall tile there and it's like a ground tile. It's missing. So that's the one I'm going to use, but you're welcome to use any wall tile that you like. And then we'll go ahead and save our scene and we will select generate dungeon, and you'll see that we have all of our wall tiles added into our tile map. So now all we got to do is set this up so that we can use our actual walls for each of these positions and make sure that the correct wall is instantiated into the correct place. So let's go ahead and head back to our wall generator script. And in here, in our create walls function, we're actually going to make some room at the top. And we're going to create our bit mask for our tile type. So let's go ahead and say string, and then we'll call this binary tile type. And we're going to set that equal to a empty string. And then what we'll do is we'll use a for loop for each loop to loop through all of our directions, because we need to check all of our neighbors to see if they're in the floor tiles or not. So we can create our bit mask. So we'll say in directions. Okay, so first we got to get our neighbor. So that is our current position plus our direction. And then if our neighbor is in our floor tile positions, so if our floor tiles positions contains our neighbor, then our binary tile type will be increased with a 1 value. And if that is not true, then we will say binary tile type plus equals 0. Okay, so that will give us our tile types. And then what we need to do is we need to go ahead and get which tile we want to use to pass to our wall tile type. So I'm going to create a tile base here, and I'm going to call this wall tile. And we're going to use a helper function to return the wall tile that we need to use. So I'm going to call this get wall tile. And we need to pass in our binary tile type to this function. Right, then we'll go ahead and we'll generate the function. And we'll get rid of this exception. And then also real quick before we continue, let's go ahead and get this wall tile and pass that into our paint wall tile instead. So that way we don't forget. Otherwise, if we forget to update that when we try to test it out, it'll just all be default wall tiles instead of the ones we actually want to use. So we'll make sure that that's updated before we continue. Okay, so then in our get wall tile function, we're going to add some logic to convert our string of our binary tile type into an integer, which will be an actual binary number. So first we'll say int, and then I'm just going to call this tile type, and we're going to use the convert and then to int 32 to convert our string. So we'll say binary tile type. And then we want to convert this into a base 2 number, which is going to be our binary type. So we'll do that. And then at the end, we'll return our default wall tile. Okay. So that way, if it doesn't match anything, we'll just automatically use our default wall tile. And that will give us a pretty clear idea that we're missing a wall. So then we're going to need to set up our wall types helper class to return whether or not we have this tile type in each tile type, I guess. I don't know. Okay, so let's go ahead and just get this started. So in our file structure, we will create a new script inside of our dungeon generator, and we'll say new file. And I'm going to call mine wall types helper.cs. This is going to give us an empty script. So we're going to actually add our using system.collections.generic at the top, since we're going to be using hash sets. And then we'll go ahead and define our class. So this is going to be static because we want to be able to access it from anywhere without having to create an object in order to get the items out. And then we want to say wall types helper. All right, so in here we're going to define a few wall types. I'm only going to walk you through doing 2 of them, and then you'll have to set up the rest on your own. This is a bit time consuming and a little bit tedious, so I'm going to make sure that my script is up on the GitHub for you so you can reference it and even copy and paste it if you feel like it. It'll help you speed up the process, just to make sure that you use the same names that I use if you're going to copy and paste it. But to get started, we're going to create our first wall type. So we'll create public static, and this will be a hash set of integers. And this first one is going to be our top wall, and we'll set that equal to a new hash set event. And then we're going to define our hash set manually, so we'll use our curly braces. And then don't forget your semicolon at the end. Then let's copy and paste that. And then we'll also do the left wall tile. So go ahead and say left wall, and then save. All right, so now we need to figure out what bitmasks need to go in here. So let's go to Unity. And we'll take a look at our map that we have already generated. And we'll find a wall tile that's on the top of a room. So we could go here, or we could go up here. So let's zoom in here. And let's do this wall tile. And what I recommend to do is to leave your cursor here. And with your finger, point to each one you're going to do. That way you make sure that you're always going around the same wall tile. It can be easy, especially starting off, to get mixed up which one you were on and then have to start over. All right, so, but I'm going to use my mouse to highlight which ones we're on just so it's easier for you to see. So here, if we're looking at this wall tile, our first position in our bitmask is going to be 0. And we can actually see that we have a couple zeros here. We actually have 1, 2, 3 zeros. So our bitmask so far is going to be 0, 0, 0. And then we have 2 1, so 0, 0, 0, 1, 1, and then we have 3 zeros. So 0, 0, 0, 1, 1, 0, 0, 0. Let's go ahead and add that to our helper script. So for binary numbers, we have to add our prefix of 0b, and then we can add in our the rest of our numbers. So we can go 0b and then 0, 0, 0, 1, 1, 0, 0, 0, and then we'll add our comma and save. And then in our wall generator script, right after we converted our type to an integer in our get wall tile function, we'll add an if statement to check if wall types.helper.topWall.contains our tile type. Okay, and if this does contain it, oops, trying to use some curly braces is not working. All right, so if this does contain this tile type, we'll go ahead and return the tile that we want to use. So we'll say top wall tile. Okay, we don't actually have this yet, so let's go ahead and we can generate the field at the top of our class. So it's actually added it here as a private, so let's just cut that and we'll add it to our public. So let's add a header, and we'll just say tiles. I'll paste that here. We'll change private to public, and then we're good to go. That reference should be complete. All right, so let's go back down to our get wall tile, and then let's just add the if statement for our wall types helper dot left wall dot contains tile type. And then we're going to return our left wall tile. I'm not going to generate this one because that wasn't actually that helpful. So we'll just scroll up. We'll create a new public tile base. And then I'll just paste that name in there. Okay, good. So then we'll have that done. So now we have if our top wall contains it, if our left wall contains it, and then if neither of those contain it, it's going to use the default wall. So let's go ahead and save. We'll head back to Unity. And then we can go ahead and generate a new dungeon, and we should see the tile in there. But before we do that, we have to make sure that we set up our references so we can see that we don't have any tiles down here. So I'm just going to drag a couple of tiles in. So first I'm going to grab my top, and then I'll grab one for my left. Here we go. And I missed. Okay, there we go. And now when we click generate dungeon, we'll see that this position here is going to have our top wall tile. So then I'm going to challenge you to make sure that these two positions also have that tile. So pause the video here, add the bit mask to your walls tile helper, and then generate your dungeon to see if you got it right. Once you're done, come back here and we'll walk through it together. All right, so next we're going to just try to get a wall tile here and here. These two should be the same bit type, so we'll only have to do it one time. So here, we'll look at our surrounding tiles. So our top three are going to be 0, so 0, 0, 0. Then our bottom three are also all 1, so we have 1, 1, 1, then 0, and 0. So 0, 0, 0, 1, 1, 1, 0, 0. Okay, head back to your script for your wall types helper, and we'll add that in. So we'll say 0b, and then 0, 0, 0, 1, 1, 1, 0, 0. Save that. Head back to Unity. We won't need to make any further changes. And then we'll generate our dungeon. And now we should have pretty much all of our top walls in there, except you'll see that we have this corner here that could be fixed. So I'm going to challenge you to go ahead and pause the video and also get that one working. Okay, so welcome back. Let's go ahead and walk through this one together. So for this one, we'll see that we have zeros in 4 of our first positions. So we'll say 0, 0, 0, 0. And then we have 2, 1, so 1, 1, and then 0, 0. So 0, 0, 0, 0, 1, 1, 0, 0. So we'll head back to our helper script and we will add that one. So 0b, 0, 0, 0, 0, 1, 1, 0, 0. We'll add a comma. And then when we go back to Unity and let that reload, we'll click Visualize Dungeon, and we'll see that that tile is now added to that top corner for all of the ones in our dungeon. So let's go ahead and get our left tiles working. And we're not going to do any of the corners. We're just going to kind of get these left straight walls in as well. So let's take a look at this position here and start figuring out what our bitmask should be. So here we have 0, 0, then we have 1, 1, so 0, 0, 1, 1, and then we have 0, 0, 0, 0. So it's 4 zeros at the end there. So let's go ahead and add that to our bitmask for our left wall. So we'll say 0B, and then we go 0, 0, 1, 1, 0, 0, 0, 0. Save that, and then I want to just double check that one because I don't fully remember. So 0, 0, 1, 1, and then 4 zeros. Yeah, perfect. Okay, so with that in, we can go ahead and just generate another dungeon, and we'll see that we'll have that wall position now showing up for every one of the tiles that has that wall position. And then we'll do the middle one, so there'll be these 3. So let's go ahead and do that. So starting here, this is our wall position. So we'll go to the top and say 0. And then we have 3 1s, so 0, 1, 1, 1, and then 4 zeros. Let's go ahead and add that to our helper. So we have 0, 1, 1, 1, 0, 0, 0, 0. Okay, so that'll get us our middle wall positions on the left. So we generate our dungeon, we can see that. And then lastly, we need to get this bottom corner. So we'll take a look. We have 0, 1, 1, and then we'll 5 zeros. So let's add that. So we have 0B, and then 0, 1, 1, and then the rest are zeros. And head back to Unity, and we'll generate our next dungeon, and we'll see that that now has our tile position. So we're now generating a tile for that spot. Okay, so then what you're going to do is just go through every position that has this dark brown block instead of a tile, and you're going to calculate its bitmask, and then you'll want to add a new tile type for each different one. So if you're going to do the top left corner, you'll create one for top left corner and add in your bitmask, and then make sure that you also update our get wall tile. So for every new tile type you add in the tile type helper, make sure you also add an else if statement. I recommend just copying and then pasting it and then changing the type and then changing this tile that you want to use. All right, so with that, we have completed this section of our tutorial. So I want to just congratulate you on completing this part of your dungeon generation journey. You now know how to use bitmasking to identify wall tiles and determine their layout dynamically. This is a significant step towards creating a fully functional procedural dungeon. In the next video, we're going to take this even further by implementing collision on our walls, and then we'll use the level exit that we created in video 3 to further close our gameplay loop by generating a new dungeon and then teleporting our player to the start of the room. If you found this tutorial helpful, don't forget to like this video, subscribe to the channel, and then also hit the notification bell so you don't miss an update. Thank you for watching, and I'll see you in the next video.